All right, everyone, let's do number 47 and let's check over our work. Number 47 is a great example of a problem that really makes you pay attention to the minute detail of your notation. Here's the original question right here. And here is where I rewrote it as a limit in pink, okay? And then in green down below, look right here, okay? So I recognize the limit of an integral, and then I look at the indefinite integral. This is what Nicole was talking about. You've got to be really clear in your presentation of work. This is a side work down below where I'm just dealing with the indefinite integral, recognizing that I do have to use integration by parts, okay? I took care of the integration by parts indefinite integral here and then went back up. So now here I am, all right? So notice b is approaching 0 from the right. Here is the antiderivative evaluated from b to 1. Okay, let's go over here now. This is where we have to be very careful. As b approaches 0 from the right, you'll see here that I just inputted in 1 into the indefinite integral. I get this. Minus the quantity b inputted into the antiderivative. Okay, let's pick it up from here together. This is going to equal the limit as b approaches 0 from the right of, this becomes -1 minus, this is still b times ln b minus 0. Okay? The focus now turns to this entity right here. As b approaches 0, b times ln b is approaching 0 times -infinity. You have to remember this is an indeterminate form. And so what you have right here in this one question is an integral, an improper integral, and an indeterminate form. Major blast from the past. So what we have to do is be really clear with our work. We have to go down here and say to the reader, I'm going to address this limit first before I go back to this expression. The limit as b approaches 0 from the right of b times ln b, I am recognizing that this is approaching 0 times a form of infinity. You have to go back in your notes. If you want to just hear me say it, I will certainly give you the solution on what to do right now, but I will tell you this. If you go back in your notes right now and look it up, it'll make it stick in your head. So you make the right decision, knowing the demands of the course that you're in, okay? This form of infinity is this form of indeterminants is one where we say, is there a way that I can rewrite this as an indeterminate form of 0 over 0 or infinity over infinity? And if you go back and if you looked, you would have found that I could do this. When I rewrite the argument this way, I now have this situation. I have an indeterminate form that allows the use of L'Hopital's. L'Hopital's rule says that if your limit is approaching infinity over infinity or 0 over 0, you can take the derivative of the numerator and derivative of the denominator and evaluate the limit that way. This becomes now an exercise in accuracy. Everyone follow? After an iteration of L'Hopital's, what's the first thing you do before you try to evaluate the limit? You clean 1 over b all over -1 over b squared. This becomes the limit as b approaches 0 from the right of -b, this equals 0. Okay? Now we've just reconciled what this value is here. So this 0 value can get back put in. So I'm going to go back here. This is all side work, okay? This now becomes, right here, I can now simplify. This now becomes the limit as b approaches 0 from the right of -1 minus the quantity 0 minus 0. The whole limit equals -1. Therefore, the integral converged, and it converged to -1. All right? Really like 47. There's always a way to make every calculus question more cumulative than it needs to be. more cumulative than the lesson of the day, all right? So that was an excellent question. Let's talk about 51. 51 asked you to do a volume problem, okay? So let's look right here for right now. Here is the question, and the wording was so clear. It said the area between y equals e to the negative x and the x-axis is revolved around the x-axis. Find the volume of the solid. And notice the wording just said the area between this curve and this curve. And this area is infinite. And if you were to revolve around the x-axis, I tried to make a little image here. I think you probably see where we're going, which is heading in this direction where we're going to have to deal with cross-sections that are disks, right? Cross-sections that are disks. We see that in our future. And those cross-sections look like this, okay, if I were to fill it in. Okay, so now, here's a great question. I'm just finishing this. Okay, just drawing the body parts. Okay, and those are my cross-sections. Okay. Oh dear, my x-axis just went away. What happened? Oop, oop. Oh goodness, now my drawing is all lopsided. Oh well. Okay, so the first thing you do is you set up your volume integral. This is the integral. I think you'd all agree with me. And hopefully what caught your eye are the limits of integration. It's an infinite interval of integration, but there's infinity on both sides. Here I just did one more cleaning. I just took care of e to the negative x squared, okay? Now, if you look at this here, you'll notice that this function, e to the negative x, and specifically this integrand, e to the negative 2x, right? There's something going on here. Between negative infinity and positive infinity, there are no points of discontinuity. In other words, this integrand exists for all values of x. Now, I realize I have a lower limit approaching negative infinity and an upper limit approaching negative infinity, but I have to rewrite this as a sum somehow. I cannot do this. You may not do this. I know some of you are thinking this. You may not say the limit as b approaches positive infinity of the definite integral from negative b to positive b of e to the negative 2x dx. I know you want to do that, but you may not do this. The implication here is that when you write it like this, like a single integral, you're suggesting that the lower and upper limits are approaching those values in exactly the same fashion, and you cannot do that, okay? Like I said, improper integrals is all about the details in your writing that show you understand something. So the question is, how do I reconcile this? Well, what do you think? We have to write this as two different integrals. One of those integrals will be from negative infinity to something plus something to positive infinity. Where is that breakpoint? Well, because the integrand is not problematic, which means it's differentiable for every value between negative infinity and positive infinity, you can pick any value between negative and positive infinity. Whenever I'm given that option, I always go for the most convenient choice, which is 0. Okay, so this becomes, let's see, pi, I'm going to pull the pi out, times all of this. E to the negative 2x dx. All right, you understand? So that's an important thing right here. This is the important conversation we just had. When you have an infinite interval of integration, and the issue at hand is really how do you split the integral, so to speak? How do you write the integral as a sum? If the integrand exists at every value between negative and positive infinity, you can pick any value between. But I would absolutely pick the most convenient value, which is going to be 0. At this point, you're going to go ahead now and take care of this all the way through. Why don't you go ahead and take take care of it, and then check me for the answer. All right, let's go and work this out. And actually, the minute I did the solution out, when I happened to look at your textbook, I noticed that your textbook just wants you to look at the area here. X is bigger than or equal to 0. So I included more. That's okay, because you would still need to know how to do, you'd still might run into problems like this anyway. So that's all right. We'll still look at this work that I did for the question that I added onto, and then I'll show you kind of what the answer to the question in the text was. But I did much more than I needed to, or to be more clear, I did not keep track of what the question was asking in any case. Okay, so if we're going to pretend that this was asking you for negative infinity to positive infinity, we go through here, okay, and look what I'm doing. Okay, so I split the integral, and remember, again, the choice of 0, it could have been any number. It could have been 1, 5, 6, but 0, if you can pick 0 as a breakpoint, that will always be the most convenient. Then it's just making sure you keep track of just notation, just all the minutia here. Okay, so look at this line, right? Notice I did not need a superscript for these limits because you can only approach negative infinity from the right. You can only approach positive infinity from the left, right? So while you can put them there, it would be superfluous, superscripts that is. Antiderivative right here. And notice here in this line, I pulled the negative 1/2 out. It just tends to make things a little bit easier when you pull the constant out whenever you can. And then look at here. This is the point where you have to just be careful, right? As b approaches negative infinity, we have 1 minus positive infinity. As c approaches positive infinity, we get 0 minus 1. Okay? This whole thing here will then approach positive infinity, not negative infinity, because I have the negative 1/2. In the parenthesis, we have negative infinity in the parenthesis, but then you're multiplying by a negative number. So this integral diverges. And if you think about it, logically that makes sense, because if you think about it, if we were rotating the entire function, there's no way it could possibly converge, because this, you know, the volume over here just gets indefinitely huge. Okay, well, let's address the question at hand, which was just looking at this portion of it for values of x bigger than or equal to 0, which ends up actually being an easier question, okay? So really what we can do is just take a look at, here's the question right here. This is it right here, just this right-hand side from positive infinity, from 0 to positive infinity, the pi is pulled out. So basically, if we're looking at the question as it was asked in the text, we could disregard this whole piece here. And in that case, if we look at just the solid for x is greater than or equal to 0, we get then positive pi over 2, which is the volume. That's kind of fascinating. So the volume comes from the fact that the improper integral is a convergent integral. Okay? And that's a pretty neat idea if you think about it, that even though this curve goes on forever, it never will touch the x-axis per se. It gets close enough, so to speak, so that the approach to 0, right, it gets so close to 0 as to become negligible. One of the natural questions you may have is, will that always be the case? The answer is no, but more on that later. Arjun, please stop tipping. Goodbye.